Algebra 3, Trigonometry, Chapter 2, Section 3, Analyzing Graphs of Functions. When analyzing a graph, we need to ask ourselves a few essential questions. The first is, what is the domain? Then we need to ask, what is the range? Is it a function? What are the zeros or the x-intercepts? Where is it increasing, decreasing, and constant? And what are the relative maximum and minimum values? We also want to know, is it an odd or an even function? First, let's talk about what even and odd functions are. Odd functions are symmetric about the origin. Now, how you can tell that from looking at the graph, if you can turn the graph upside down and it looks entirely the same, even to the relationship or the closeness of the graph to the axes, then it is odd. The highest power degree is often an odd number. Now, that's not going to be true all the time, but it's often associated with functions where the highest power is odd. Even functions are symmetric about the y-axis, and the highest power or degree is often, but not always, an even number. Now, average rate of change. Whenever you see average rate of change, I want you to think slope, because that's all the average rate of change is. It's the slope between any 2 points that lie on the graph of the function. Now, that's not saying that there is a straight line between those 2 points. In fact, the graph may curve greatly between the 2 points. But the average rate of change is the slope of the line that you could draw between the 2 points. And again, remember that our formula for slope is rise over run, or delta y over delta x, or y2 minus y1 over x2 minus x1. Now I want you to try to find the zeros of these two functions algebraically. Remember, the zeros are the x-intercepts. They are where the function equals 0. Pause the recording, give it a try, and resume the recording to check your answer. For our first function, we really only care about the top, because if the denominator equals 0, then the function is going to be undefined. So the 0 of the function is where the numerator equals 0, and that occurs when x is 0. Our second equation, we're going to set it equal to 0, add 1 to both sides, square it, well, 1 squared is 1, and then divide by 2, so x equals 1/2 will be the 0 of this function. Now you can find them graphically using your calculator. For this example, you're going to graph these on your calculator, and then you're going to determine where the function is increasing, decreasing, or constant. Now these are going to be intervals, so you're going to give me the x values. As you look at the graph, as it goes from left to right, you're going to give me the intervals for x, where this function is increasing, going up, decreasing, or going down, and constant, which would be flat. Pause the recording, give this a try, and resume the recording to see how you did. Okay, this first equation gives us a parabola, and the parabola is decreasing when x is negative. In other words, from negative infinity to 0, it's decreasing. And then it's increasing when x is positive, or from 0 to positive infinity. Our second function is decreasing when x is less than 1, or from negative infinity to 1. In fact, that's the entire domain of the function. It doesn't go any further than that. So it's actually decreasing over its entire domain. Now you're going to graph and calculate the maxima and minimum values of each function. Now to do this, you have a function on your calculator. If you hit second trace, there's one for maximum and one for minimum. You want to use these rather than try to figure it out yourself using trace on the graph. So using the calculate functions of maximum and minimum, find the maximum and minimum values for each equation. Pause the recording to try this and resume the recording to check your answer. Our first function has a minimum value at 0.33 for x, negative 5.33 for y. Our second equation has a minimum value at 0.33 for x and negative 0.38 for y. Now you're going to find the average rate of change from x1 to x2. Now remember, the average rate of change is slope. To find the slope, you need 2 points. You need an x1 and a y1, and you need an x2, y2. They're giving you the x's, and they're giving you an equation to find the matching y. So the first thing you need to do is put each of these x's into the equation individually and find the y value that goes with it, and then use the slope formula. Pause the recording to do this, and then resume the recording to see how you did. Okay, the first thing we find are our y values, and for x1, it has a matching y value of negative 3, and x2 has a matching y value also of negative 3. Putting these into our slope formula, we have negative 3 minus negative 3 over 1 minus 3, which is 0 over negative 2, which is 0. Now you're going to determine whether these functions are even, odd, or neither. Graph them and look for their symmetry. Pause the recording while you do this and resume the recording to check your answer. Our first function is odd, which means it's symmetrical with respect to the origin. That means that if you turn the graph upside down, it should look exactly the same. And our second function is neither even nor is it odd. It's not symmetric with respect to the y-axis or to the origin.